question over here is minimum path sum. Now you are given a grid of non-negative numbers. You have to move from top left to bottom right, and at the end you have to return the sum. Now you can only move either down or right at any point in time. There are two solutions. First is 1D, second is 2D, and this 1D is basically an optimization of this 2D. So I'll start with this 2D version. So firstly, you start with m equals to length of grid. N is the length of grid of 0, which is the column. Then dp is 0 times of n for I in the range of m. So you assign this dp grid. This is the starting cell, so dp of 0, 0 is equal to grid of 0, 0. So this one. Now you're building another 2D version of this dp, and it's the size of the existing grid. So now you start filling. So this is the first row. The first row can only arrive from the left. So for j in range 1 up till n, dp of 0 j equals to 0 j minus 1, which is the one on the left, plus grid of 0 j, so the existing value. Then this second one is how we fill our column. So it can only arrive from the above. So for I in range 1 up till m, dp of I0 is equals to I minus 1. So if this is I, then this will be I minus 1. So we are arriving from above, plus grid I0, which is your current value on the grid. So you have that. Once your dp array is completely filled, then you will iterate through. So for I in range 1 until m, for j in range 1 until n, dp of ij equals to grid of ij plus minimum. So what we are doing is we are filling the rest of the dp array, and the way we are doing that is that we are taking the cheaper of the above and then of the left. And at the end, dp, we are returning dp of m minus 1 and n minus 1. So we will return the bottom right value that will guarantee the cheapest path. Now we have a space optimized version. So at every point, we are just using the two values. We are not using the entire grid at one point. So we are just using two values, which is the row above and on the left, right? So I minus 1 and j minus 1. This is what we need. So instead, what we can do is we can just keep track of one dp array as well, which is this solution. So it starts with in the same way, which is getting the dimensions of the grid m and n. Now this dp equals to 0 times n. So dp of j, it holds the minimum path sum to reach the current row's value in column j. We assign this dp of 0 equals to grid of 0, 0. So the starting point, same as this. Now for j in range 1 up till n, so we are initializing the first row. So when we are initializing the first row, we are checking at the value which is before us. So the previous value, and we are adding the current value to it. Once we have initialized the first row, then we process the remaining rows. So for I in range 1 until n. Now this dp of 0, now the first column can only come from above. So dp of 0 plus equals, we are adding the value of the grid. Then for j in range 1 comma n, we are basically doing pretty much the same thing, getting the minimum from the getting the minimum path. So from the left, so over here, we are doing dp of j. So dp of j equals to minimum of dp of j itself or dp of j minus 1 plus we add the grid's existing value. But assume you have this row, right? So the existing value at this point basically contains the value which was previously computed. So the row above us, it already contains this, right? So when we are saying dp of j, then we are taking into account the row above us because that's how we computed this value, dp of j. And then dp of j minus 1, which is the one before. So for example, this cell will have the minimum of either the minimum that was computed before us, right? So which took into account the row before us, the row above us as well. So when we say dp of j minus 1, when we just take into account this value, this cell, to compute, when we're computing this, we take into account just dp of j minus 1. We are technically taking into account the row above us because that's how this is computed. This whole row is computed like that. From the row above us, we took into account the row above us plus grid of ij, and then we return dp of n minus 1, which means the last cell.